So going back to our question, we said we board the members. After boarding them, we cut through an imaginary line through the members. Then we will draw the freeboard diagram of the upper part with the least unknowns. Okay, so we are going to have that freeboard diagram. So this member, it's just that member which to cut in. So that's the member there. Okay, then this one is the one which is here. Okay, then this one is the one which will be here. Okay, so we said we have to assume all the unknown forces as tensile forces, so I'll assume them as tensile forces. Okay, so after assuming them as tensile forces, we are going to apply the equations of equilibrium, which is the summation of the moments is equal to 0, and so I'll say summation of the moments at any point is equal to 0. I'll start with that. So now basically here you have to pick a point or your pivot. So the best point to pick is the point where most of the forces are going, so that we can erase them. Okay, so I'm going to pick this point, which is point F, as my pivot. So I'm going to find the summation of the moments at F is equal to 0. So that's what I'm going to do. Okay, so if I do that, we are going to say our pivot is there. So we have that force. Okay, if our pivot is there, yeah, so before even proceeding, we are going to label our forces. So for this one, we are going to label it as what? Force BC. Then this one we have C, force CF. Then this one we have force EF. Okay, so we are going to have that. So I'm saying we'll pick our pivot there, so that this one we exclude it, this one we exclude it, and this one we're going to. So we're going to have this force which we're applying in that direction, which is clockwise. Okay, then we also have okay, so and this one just pointing downwards. So here we already have a force here which is 4, that, but the one which is here, which is 8 kilonewton, we will not consider it. So 8 kilonewton will not consider it because it's passing through the pivot. So we won't consider that one and that one with its respective distance. Here we have 1.5 meters. Then for this one, from the pivot there, it is the same 1.5 meters. So we are going to make some equations. Okay, so we also have this distance here, which is 2 meters. So from the pivot, this force, which is 4, so we're going to say 4, it is anti-clockwise, so it is negative. Then open times its distance, which is 2. Okay, and we also have this one. Okay, so which is negative FB C, then open times the distance there, which is 1.5. Okay, cross, then everything we equate it to 0. So if we compute this, let's see our result. So we're going to have 8, then that, so we'll take the 8 the other side, which will be positive, then we'll divide by negative 1.5. Okay, so we cancel there, so that remain with F B C is equal to, okay, so we're going to have negative 5.33. okay, so since it's negative, it just means that it's compression. Our assumption, which we have assumed that this tension is wrong. So our final answer should be a positive answer, which is 3. Then we say it's compression, not tension, compression. So this is how we have to represent our final answer. Okay, so we'll proceed. So let's proceed to the next equilibrium equation, which is summation of the forces in the x is equal to 0. So we're going to have the summation of the forces in the x, and we equate it to 0. So in the x, we have how many forces do we have? So we have this force, that force, yeah. So what? So here, take note, we should not be using this diagram, but you have to use our freeboard diagram for everything. So summation of the forces in the x, we won't have that, yeah, which is pointing in that direction. Okay, so we are going to say summation of the forces in the x. We have this, which is 4, 4, which is it negative? So it's pointing in the positive x-axis, so it's positive, so it's positive 4, like that. Then so positive 4, then minus this force, which is pointing in the negative x-axis, which is minus f c f. Okay, then equals 0. I hope you are able to see that. So now this will just cross the cosine like that. So we have FCF is equal to what? 4. So since it's positive, it will be what? A tensor force. So that's how I have to represent your answer. Okay, so we'll do the summation of the forces in the y. So summation of the forces in the y is equal to 0. So we are using the same diagram here. So if you can see, we have this force pointing downward. We also have this other force pointing also downward. So in this case, our m, we have found the summation of the forces in the x, and we have found CF. So we have found CF. What have we found also? We have also found BC. Okay, we have also found BC, which is here. So here our aim is to find what? EF. So summation of the forces in the y. So we are going to have BC. So we're going to say force BC, which is pointing in the negative y-axis, so it will be negative. Then we also have force EF, which is pointing also in the negative y-axis, so it will be negative force EF, then equals 0. So from here, I think our BC, we found our BC as 5 point. So here when depressing, since it was negative, always repress as negative, because whatever we answer in here, like I've been saying, we are assuming as tensor. So the negative just told us that it was not supposed to be tensor, but it is what? Compression. So we are going to replace with a negative here. So I'll say open, okay, then negative 5.33, then we close, then minus f e f, then equals 0. So we're going to have something like that. Then there it will come out as a positive answer, then minus e f f, something like that, then equals 0. Okay, then the EF will close the equal sign. So we're going to have F is equal to 5.33, and this is positive, so it's tensor. So this were our answer to the questions. Okay, so we'll do the same question but with different members. Okay.